In the vastness of the universe, Earth is the only known planet to harbor life. But as scientists search for exoplanets in the habitable zone, the question arises: could animals adapt to the extreme conditions of a distant world? Exoplanets, planets that orbit stars outside our solar system, vary greatly in their environments. Some exoplanets are Earth-like, with conditions potentially capable of supporting life. Others are worlds of extremes, planets with scorching temperatures, powerful storms, or thin atmospheres. These planets challenge the very idea of what life can endure. Could animals or life forms in general evolve to survive under such harsh conditions? To answer this question, we must first explore the factors that influence how life adapts to its environment. On Earth, life has evolved over billions of years, shaped by forces like gravity, temperature, and atmospheric composition. But what happens when these factors are dramatically different, as they would be on an exoplanet? The answer lies in the remarkable adaptability of life. Life on Earth has adapted to every extreme, from the freezing depths of the ocean to the boiling hot springs of volcanoes. Animals have evolved in ways that allow them to endure extreme temperatures, radiation, and even the absence of oxygen. These adaptations raise the question: could life adapt to the extreme conditions found on distant exoplanets? Let's begin with the role of temperature. On Earth, animals have adapted to temperatures ranging from the freezing polar regions to the sweltering deserts. But on some exoplanets, the temperature extremes are far more severe. For example, planets orbiting red dwarf stars, which are cooler than our Sun, could experience much colder temperatures. Could animals on these planets evolve to survive in freezing conditions far colder than Earth's polar regions? It's not outside the realm of possibility. On Earth, we already have creatures like the Arctic fox and the tundra's hardy mammals that can endure sub-zero temperatures. In even colder exoplanet environments, life might evolve with specialized antifreeze proteins in their blood, similar to how some Antarctic fish have evolved. These proteins allow them to survive in water that would freeze most creatures solid. On an exoplanet, creatures might evolve to have thicker fur, dense fat layers, or even specialized metabolic systems to retain heat. Alternatively, on planets with extreme heat, such as those near their parent stars, life might evolve in completely different directions. Animals could develop reflective exteriors like some Earth insects to reflect the intense radiation from their stars. These creatures could evolve with heat-resistant exoskeletons or specialized internal organs capable of withstanding the heat. Some exoplanets may have extreme day-night temperature fluctuations. A creature on such a planet might evolve to be nocturnal, only active during the cooler nights while resting in the heat of the day. Alternatively, life on a planet with perpetual daylight or darkness could develop ways to tolerate a constant, unchanging environment. Such creatures might have evolved a slower metabolism, allowing them to conserve energy and survive without the need for regular periods of rest. Gravity would also play a crucial role in shaping how life evolves on an exoplanet. Exoplanets with stronger gravity would present a significant challenge for any form of life. Animals on these planets would need to adapt by developing stronger muscles and bones to support their increased weight. They might evolve to be more compact, with short, thick bodies and strong, stocky legs to support their frame. On planets with lower gravity, like Mars, life might evolve in entirely different directions. Creatures on these planets could grow taller or more elongated, with longer limbs or necks due to the reduced pressure on their bodies. In a world with gravity weaker than Earth's, animals might evolve to glide, using their elongated bodies to sail through the air with ease. The atmosphere of an exoplanet would also greatly influence how animals adapt. On Earth, life thrives because of our breathable atmosphere, made up of nitrogen and oxygen. But on an exoplanet with a different atmospheric composition, animals might evolve to breathe entirely different gases. On a planet with an atmosphere rich in methane, for example, Animals might develop specialized respiratory systems to process this gas, much like Earth's methane-eating bacteria. If an exoplanet had a carbon dioxide-rich atmosphere, life could evolve to use carbon dioxide as a primary energy source, similar to how plants photosynthesize. Animals on such planets could rely on chemical processes instead of oxygen, potentially evolving an entirely different form of metabolism. Planets with high levels of radiation could present even greater challenges for life. The surface of an exoplanet near a star with high radiation would be harsh and unforgiving, with radiation levels that would harm or even sterilize any life form. Yet some Earth organisms, like tardigrades, are known for their resilience to radiation. These microscopic creatures can survive in space, enduring radiation and extreme temperatures. On an exoplanet exposed to high radiation, life might evolve similar defense mechanisms. Animals could develop thick, radiation-resistant skin, like the shells of certain Earth mollusks, or even evolve the ability to repair their DNA quickly to avoid the damage caused by radiation. This ability to survive in harsh environments could extend beyond just radiation. Animals might develop ways to withstand violent weather conditions, such as hurricanes or torrential storms. On exoplanets with extreme weather patterns, creatures might evolve low centers of gravity to stay anchored to the ground, or have highly flexible, resilient bodies to bend with the wind. They might also develop specialized senses to detect changes in the atmosphere, such as enhanced hearing or vibrations, to anticipate storms. In the vast majority of exoplanets, water will still be a critical resource for life. Earth's oceans, lakes and rivers are fundamental to life here, and on an exoplanet, water, or some liquid substitute, might be equally vital. Exoplanets with oceans of liquid methane, rather than water, would need animals to evolve to survive in an entirely different chemical environment. Creatures might have evolved to breathe methane or other gases and use them as energy sources. In such an environment, animals might develop bodies that resemble Earth's marine life, but adapted to a world without oxygen. On planets with little to no liquid water, animals might evolve to survive in dry, arid environments similar to Earth's desert creatures. They could have the ability to extract moisture from the air, or they might be able to survive without liquid water altogether. Such animals could have highly efficient metabolic systems that allow them to survive on minimal resources, storing energy for long periods. One of the most fascinating aspects of life on exoplanets is the potential for entirely new forms of life. With different chemical compositions, atmospheric pressures, and environmental conditions, the possibilities for alien life are virtually limitless. Animals on these planets could look nothing like the life forms we're familiar with, evolving in completely unfamiliar ways. They might not even share the same biochemical foundation that we associate with life, potentially using elements like silicon instead of carbon. The diversity of life on Earth is a testament to the incredible adaptability of organisms. From the deepest oceans to the highest mountains, animals have evolved to survive in the most extreme conditions imaginable. On exoplanets, this adaptability could be even more pronounced. The ability of life to evolve and adapt to any environment could be one of the most exciting prospects of the search for alien life. Exoplanets provide a glimpse into the unknown, a place where life could exist in ways we have never seen before. Could animals adapt to these extreme conditions? With the right mix of factors, temperature, gravity, atmosphere, and water, life could not only survive but thrive on distant worlds. The possibilities for evolution are limitless, shaped by the forces of each planet. And as we continue to discover more exoplanets, our understanding of what life can become will only deepen. Life may be more adaptable and diverse than we ever imagined. In the future, perhaps the greatest discoveries we make about life will not be on Earth, but on worlds far beyond our own.